In this video, we'll be utilizing our knowledge of ratios to find unit rates, to find equivalent rates, and to apply ratios to real-world problems. So now that we've talked about ratios in general, we're going to start looking at very specific types of rates, and rates involve ratios. So a unit rate, if we define it in our notes, is a rate with a denominator of 1. So essentially what we're going to do is we're going to simplify the three fractions below with their units to have a denominator of 1. So if I look at this first one here, I notice that it currently has a denominator of 12. And if I wanted to make it have a denominator of 1, I would need to divide the denominator by 12, because 12 divided by 12 is 1. So if I divide the denominator by 12, I also have to divide the numerator by 12 to keep this fraction consistent. That's basically simplifying our fractions. So if I take $60 divided by 12, I get $5. And if I take 12 people divided by 12, I get 1 person. So in this particular situation, the unit rate, or the situation with a denominator of 1, becomes $5 per 1 person. So you can see how that's a rate. It's comparing two quantities there. Then if I look at this next one, I can see that I have 140 words divided by 4 minutes. And again, I remember that a unit rate, think of unit as 1. A unit rate has a denominator of 1. So I need to get a 1 in my denominator. So I divide the denominator by 4 as well as the numerator by 4. So 140, if I use my calculator, divided by 4 is 35. So my numerator becomes 35 words. I want to keep my units there so I remember what this rate represents. And 4 divided by 4 is 1 minute. So whatever this is, a reading rate or a typing rate, it's 35 words per 1 minute. And again, denominator of 1 is what makes this a unit rate, because it has a denominator of 1. Then this last one, it contains a decimal, which is sometimes a little weird. But again, it's that same process if I want my denominator to have a denominator of 1. So currently my denominator is 2.5. I'm going to divide by 2.5 in both the denominator and the numerator. So 80 divided by 2.5 is 32. So we end up with 32 ounces. And 2.5 divided by 2.5 is 1 serving. So whatever this is, whatever type of food this is, 32 ounces is the equivalent of 1 serving. So again, unit rate is denominator of 1. So now that we've looked at unit rates, we're now going to look at something called an equivalent rate. An equivalent, you should know, essentially means equal. Sorry, that was bad spelling there. But we have an equal rate. And so we're going to start with situation A, and I think you'll catch on very quickly. So an equivalent rate, we're trying to find something that's equal given the circumstances. So here in this first one, we are taking 12 calls in 1 hour. That's how many calls you're taking at your job, let's say. And we want to figure out if you're taking about 12 calls per hour, if you worked for the entire day straight, did the entire day, didn't take any breaks, how many calls would you take in 1 day? Well, notice here that hours and days are not necessarily equivalent, but we can kind of switch between them. What we know is that there are 24 hours in 1 day. And so what I can do here is I can think, well, to get from 1 hour to 24 hours, I would need to multiply the 1 by 24 in order to make it the equivalent of a day. And remember, if we're going to multiply our denominator by 24, to keep it equivalent or the same, we would need to multiply our numerator by 24. So if I have 1 hour and I'm turning it into 24 hours, I'm multiplying it by 24. And as a result, I take 12 and I do the same. So 12 times 24 gives me 288 calls in 1 day which remember is the equivalent of 24 hours. So it's just determining that how many calls you have in your new situation of one day, and just using what you know about hours and days and their relationship to help you figure that out. If we look down at the next one, what we notice here is it says we have 1,200 students for 30 teachers in the whole building. So this is a pretty big school. We've got 30 teachers with 1,200 students, and we're trying to figure out how many students should maybe be in each homeroom. Well, here I can see I'm taking 30 and I'm turning it into a unit rate with 1. As I do that, I need to divide 30 by 30 to get 1. Which means I also need to do the same thing here with the 1,200. I need to divide it by 30 in order to figure out how many students each teacher will need to take on. So if I take 1,200 divided by 30, I find that I have 40 students per one teacher. And notice that in each situation, this also still makes sense. So here, for decreasing the number of teachers, it makes sense that we're dividing those students up evenly and decreasing the number of students so that we're figuring out how many per teacher. Up here in this first example, we took an hour and extended it to a day, which means that we would expect to make more calls in a complete day than we would in just an hour. All right, and this last example here says we travel 25 kilometers in 1 hour. And then I notice I'm trying to figure out how many, this should be kilometers here, sorry for the confusion. How many kilometers do I travel in 1 minute? So I notice here again I have unequal units here, but what I do know is that in 1 hour there are 60 minutes. So that's something I know about the relationship between hours and minutes. Now I know that I can travel 25 kilometers in an hour, which means in a minute I should ultimately travel less. So here I see I'm going from 60 minutes down to 1 minute, so I'm dividing by 60. Which means I'm going to have to take that 25 and divide that by 60 as well. So 25 divided by 60 is 0.41, and then I'll round it to 7 kilometers per 1 minute. Now that might seem a little weird, but if you realistically think of it, you travel 25 kilometers in 1 hour, which means that you're going to travel less than half a kilometer in a minute. That would make sense because an hour is quite a bit longer than a minute. So we have to take those 25 kilometers and divide them evenly among the 60 minutes that we have in that hour to figure out how far we traveled in 1 minute. So all of this is a lot about using your logic and your common sense to figure out how do I make it equivalent to this new situation of 1 day, 1 teacher, or 1 minute. So now let's apply our knowledge of ratios to start analyzing some different situations. So here it says you are at the store to get some soda. Pepsi is on sale for $3.98 for a 12-pack. So that's what I know about Pepsi. Pepsi is on sale $3.98 for 12. Then you have Coca-Cola is on sale for $5.99 for a 20. So we have Coca-Cola on sale for $5.99 for 20. So I have to figure out which one is the better buy, which honestly is a pretty true situation that you run into when you run to the grocery store. So here, what I need to figure out is I need to figure out what is the cost per 1 can in each situation, because that's really what I can compare. So what I'm going to try to figure out is how much it costs for a single can in each situation. And notice that my order here is going to be very important. I want the cost per, that line can mean per can. I don't want the can per dollar. I want the cost per can, how much it costs for each can in each situation. So I'm going to create that ratio. So here I have $3.98 for 12 cans. And what I'm going to do is I'm going to turn this into a unit rate by dividing each of those by 12. So I want the cost per single can. So if I take $3.98 and divide it by 12, I determined that it will cost about 33 cents per one can. So that's what Pepsi's deal is. Essentially, if I divide that out, it's 33 cents per one can. Now, if I do the same situation for Coca-Cola, I have $5.99 for 20 cans. So again, I'm going to turn each of these into a unit rate and figure out the cost per can. So $5.99 divided by 20. So I get 0.2995, so that's about $0.30 per one can. Now, if I think about this, realistically in this situation, would I rather spend 33 cents per can or 30 cents per can? Well, I always like to shop for the best deal, so I would rather spend this 30 cents per can because that's a little bit cheaper. I'm getting a little more soda for my dollar. And as a result, the Coca-Cola is the better buy. So we can use our knowledge now of all different types of rates to determine what's the best deal in a real-world situation. And our last ratio problem for the day. So it says in 1 hour, four club members assemble 320 newsletters. What is their assembly rate per person? So what I need to do here is I need to set up a ratio that will allow me to find the assembly rate per person. Now the key here is reading what they asked in this last sentence right here, because that's telling you how to set up your ratio. It's saying assembly rate, so this is assembly per means my fraction line or my ratio line or the colon or the word to person. So the person has to come second. So assembly is this 320 here. We are assembling 320, and we currently have 320 newsletters for 4 people. And I am essentially trying to figure out how many newsletters are being assembled by each person. So what I need to do here is turn this into a unit rate. So we're going to take 320 and divide it by 4, as well as 4 and divide it by 4. So 320 divided by 4 is 80 newsletters, and 4 divided by 4 is 1 person. So I can take the information that I knew and determine that if everyone is dividing up the work equally, there are about 8 newsletters being assembled by each person.